Hello. In today's video, I will be demoing some of the new features recently added to the Strike and Dip Virtual Reality Tool project. The first feature that I will be demoing is the new Leveler tool. As you can see, a spherical version of the level has been added to the bottom of the compass here. As the user rotates or moves the compass, this sphere always points up. This tool has been added so as to help the user more easily tell when they have positioned their compass at a level plane. The second version of this tool is a cylindrical slide level. With this version, you can see that there is a sphere trapped inside of a cylinder, and as the cylinder tilts or moves, the sphere moves to the highest point along the cylinder. This cylinder also can be rotated, and no matter how it is turned or twisted, the sphere inside will always be pointing up. Currently, we have implemented a version of the spherical leveler tool to the base of the compass. However, a version of the cylindrical slide leveler tool could also be added for certain functions. The next feature that I will be demoing is the copy or duplication function for the beginner's tool and strike and dip arrow node sets. These duplications allow the user to make a copy of a set of strike and dip arrows and move that copy around the environment. However, no matter how the user twists or turns the copy that they are holding, the copy always retains the same strike and dip orientation on its arrows. This allows the user to take a copy of one of their measurements to a different location around the environment to either compare it to a secondary measurement or to take measurements of it to practice themselves. The second feature that I am demoing here are the new stationary versions of strike and dip arrow sets. These stationary versions are sets of strike and dip arrows that can be placed around the environment to direct the user as to where they should be taking a measurement of their own. These stationary versions also have two options for them. One in which the data represented by their arrows is expressed above them on a small menu, and one option that hides that data. In the first case, arrows can be placed around the level so as users can go and test out their measurements and immediately have a feedback number to compare to. In the second circumstance, these stationary arrows could be placed around the level in more of a quiz fashion. Whoever sets up the scenario can set these arrows around. The user can take measurements off of those hidden data arrows and then turn in their measurements to the instructor or whoever has set up that particular scene. As you can see here, I'm placing the compass on the strike arrow and rotating the face of the compass to point north. Although this does not affect the actual measurement of the strike taken by the compass, it is good practice for the student or the user to know how to physically read the compass themselves. Here I can be seen placing the compass vertically, getting ready to take the dip measurement, rotating the compass face so the clinometer on the bottom of the compass face lines up with the downward pointing ground arrow. Now I'm positioning the compass along the dip arrow, getting ready to take the dip measurement. Now that I've taken the strike and dip measurements with the compass, I can compare the numbers or the data taken by the compass on the heads up menu against the data of the strike and dip arrow set represented on its smaller local menu. Although my measurements are off by a degree or two, or this is a normal amount of user error, this shows the user that their measurements are relatively correct within a couple of degrees of human error. On this secondary duplicate set of strike and dip arrows from node number 2, you can see that the data has been hidden. So no strike or dip measurement data is floating on the small menu above this arrow set. The user can still position their own compass to take measurements from this arrow set. The next feature that I will be demoing is the beginner's tool, or the strike and dip node set. With this beginner's tool, the user can rotate the tool to point the strike in any direction they would like. However, no matter how they rotate the tool, the strike always stays parallel to the ground, and the dip arrow always stays at a 90-degree angle to the right of the strike arrow. Once the strike arrow has been placed, the user can grab the dip arrow and rotate it downwards to match the slope of the dip they are trying to measure. Once this tool has been placed, the user can click the Save Strike and Save Dip arrows to gather the data from the position of the beginner's tool. Once they've taken these measurements, they can also make a copy of the position of the beginner's tool. This copy, like the previous duplications or copies, will retain the direction of the strike arrow and the dip arrow from its parent set of arrows. This allows the user to move those copies around the environment and compare them to other sets of strike and dip measurements taken. The next feature I will be demoing is the Scaffold platform feature. Because the user can teleport anywhere around this environment, including onto the steep sides of very high cliffs and rock faces, some users who are not acclimated to VR may find it very disorienting to find themselves standing in midair 10, 20, or 100 feet above the ground or above a vertical drop. So we added a function allowing the user to place scaffold platforms at their feet wherever they are around the level. In this portion, I can be seen teleporting onto the steep side of this outcrop, clicking the New Scaffold Platform button, which places these gray scaffold platforms at my feet. Once a scaffold platform has been placed, the user can teleport to any point on top of that scaffold platform. Here I can be using it to set a new set of strike and dip arrows or a new beginner's tool on the slope that I teleported up here in order to measure. Once the user is finished using these scaffold platforms, they can clear the platforms away by simply clicking the Delete Scaffold Platform button on their in-game menu. This will clear all of the platforms from the scene. The user can place as many of these platforms as they would like. The next feature I will be demoing is the new Level Select feature. This feature allows the user to switch between different scenes or different levels within the project. The level I am currently showing is a landscape map of the Tarlair structure. This model is being used from Sketchfab and is of the Tarlair Landscape. The Tarlair arch used in the previous scene can be seen here along with the landscape that normally surrounds it. Many of these landscape outcrops have been set on top of a flat plane containing a satellite image of the area. This allows us to rotate the landscape model so as to, as close as possible, georeference it, meaning that north within this landscape should, within a couple of degrees, equate to north in its real-world orientation. This next landscape that I am demoing is the Clashach Landscape. I apologize if I mispronounce any of these location or model names. Here, once again, I can be seen teleporting up onto a very high and steep cliff face, then placing a scaffold platform so as to feel a little bit more comfortable, not just floating in midair. I'm once again placing a version of the strike and dip set node or the beginner's tool against this rock face, taking the strike and dip measurements from it. This next landscape I will be touring is the Amroth structure. This next structure I will be touring is a formation from Stackpole. Unfortunately, unlike some of the other formations, I was unable to locate the real-world latitude and longitude of this structure, and because of that, I was unable to find a satellite image to georeference this structure against. Here I can be seen once again creating a new strike and dip node or a new beginner's tool, placing it along the strike of the surface, then rotating the dip arrow down to match the slope of the surface. By then clicking the Save Strike and Save Dip measurements, the strike and dip data has been saved to the node. This final area that I will be demoing is a work in progress map that has pulled together a number of different geologic outcrops of varying sizes. The idea of this map is to pull together a number of different examples of different structures that can be used in one continuous educational space. This particular map is very much still in an early prototype phase. Everything within this project is a prototype, but this level is one of the newest additions. Thank you for watching, and we will have more updates soon.